Hi everyone, and thank you for joining us. We're here today at Toloka platform, and we've gathered together to talk about different problems related to training and evaluating multilingual models. So I have quite a dense program for today. And so we'll have some talks, and I ask you to put your questions on chat, and then after the talks, we'll have a time for question answering. But unfortunately, due to the density of the program, we cannot take all questions together with the talks. So please just put everything on chat, and either one of the speakers will be able to answer in the chat after they are finished, or we'll take the questions during the panel, which would be the second part of today's webinar. Uh, Right. Without further ado, let's get started. And Ahmet, the floor is yours.
Thank you. Hi, everyone. First of all, thanks for having me in the webinar. It's very nice. I hope I will manage my time to use efficiently. We'll see. So I am Ahmet. I am a researcher at Cohere or Cohere Labs. Actually, we very recently changed sort of our lab name. Today, I'm going to talk about multilingual post-training. So, the multilinguality is the topic of this webinar. But I actually want to tell a story about because some of you may know we have a model family called Aya. But beyond the model, actually we have a multilingual research ongoing, maybe almost 2 years, that we built from Aya 101 to the Aya Expanse. Even we extended to the vision language models. But I would like to tell a bit of different flavors of multilingual post-training. So starting from Aya 101 model. So in last year, February, we released this Aya 101 model together with the Aya dataset, which is probably the most important part of multilingual post-training, the data. Then moving forward, we released Aya 23 models that was more performant because has more powerful base model and much less languages to optimize for. And then going to the Aya Expanse, there we actually experimented with much more different ideas that has been published separately, and we combine all these sort of different flavors of multilingual post-training, including model merging, RLHF, or synthetic generation, and we released last year, October, Aya Expanse. So that today I try to briefly explain what we did from Aya 101 to Aya Expanse. But before all of this, I think there are this expectation for multilingual modeling, right? We want to leverage from cross-lingual transfer. This is potentially why we really training multilingual models. We want to make models more inclusive, more accessible, and we want one model for all. So this is the expectation, and this is like the ideal scenario. But some of you probably knows the reality is much more challenging because there are lots of difficulties comes with the machine learning problems and human challenges, as in the context of data collection. So it's really nice place to research if you look at in that perspective. Starting from Aya 101 and more focus here, actually the Aya dataset. So to train a very strong multilingual large language model, first thing that we need is obviously it's a high quality multilingual data and the right mixture to train model on it, right? So the Aya model actually kind of represents this angle because this was a really large project with lots, maybe like 3,000 people that joined in different degrees, that we collected the multilingual data, we created synthetically or using translation loss of multilingual data. Also, we train model with lots of experimentation to find the right mixture. And this was a massively multilingual model, meaning it was actually trained for 101 languages. So this is the datasets that I was talking about. The Aya dataset is the human-created part of the data, potentially much more high-quality portion of the dataset, but much smaller volume. Like I think it was 200,000 data samples, so it is not really enough for 101 language use case, right? Beyond the Aya dataset, then we had actually this Aya collection that we carefully picked lots of different characteristics of data, and then we machine translated. But that in total, this was, I think at the time, maybe still, is the largest volume instruction fine-tuning dataset that covers 101 languages. And together with the dataset, of course, you can train model as performant as possible only if you have evaluation, right? So together with the IA dataset, we actually also released this IA evaluation suite that match a little bit more real world scenarios that we can compute like a win rates or make the model comparison. So I will, of course, I will skip all the some details here. So feel free to raise the questions later on. But the IA dataset, when we were building, particularly designed for really real world use cases. So we looked at completion length, generation length. We looked at the fluency in multiple languages, and this is actually this results showcase when you have high quality multilingual instruction fine-tuning data, then you can really excel in open-ended generations, which is much more kind of reflecting the real world cases. So the baseline here is MT0 at the time. I think still one of the strongest model in massively multilingual large language model. So it also includes, I think, 101 languages. And the IA was also fine-tuned from the same base model. But if you look at the win rates, there's a dramatic difference, right? This difference is actually really stem from the data set. But not only for this open-ended generation case, if you look at more conventional benchmarks, IA model was also still outperforming the baseline because together with the quality in the dataset creation, the mixture and the diversity in terms of languages and diversity in terms of tasks is really important. And IA 101 also represents this finding the right balance between languages and tasks. And the result of this right balance, we had actually improvement across multiple different tasks. So through the IA 101, which was more focused on really supervised fine-tuning, but actually beyond creating a large volume multilingual supervised fine-tuning dataset, when going to the IA expense, we actually did lots of different research that I will briefly mention now, from the different flavors of post-training, like reinforcement learning from human feedback, which is kind of fundamental piece of today's large language models, model merging or synthetic data generation, and it end up IA expense. Now I'd like to tell a little bit of this. So in the IA 101, actually we had this synthetic data observation that synthetic data, even with the simple translation, tends to be beneficial if the quality is high. I'm not saying like always beneficial, but it's the one way to use it. But actually there are lots of limitations with the translation, right? But now there are much more strong large language models that you can actually distill information through the dataset, synthetic data generation. This is very well-known idea. It's nothing new. But in the context of multilingual LLMs, there are strong teachers that are strong in different languages. If you only rely on one teacher, you may not really learn the highest quality information, right? So the multilingual arbitrage idea was exactly focusing in this angle. So we built a team of teachers instead of using one teacher only. And for each prompt, we generated multiple completions for all the languages. And based on some sort of smart routing, could be reward routing or could be much smaller classifier, we route the best completion per prompt, which is also obviously per language. And with this idea, we have much better quality of multilingual synthetic data. So that was the first flavor. And this is the paper that is separately published, but then we combine in IA expense model. The second piece of IA expense was multilingual reinforcement learning from human feedback. RLHF also is pretty standard these days, but I still say I would think still there is much less work in multilingual setting for RLHF. And in this paper that I list here, we really focused on, okay, how can we use RLHF techniques in multilingual for multilingual LLMs, and what are the important points that has been less observed in like a more English-only evaluation or English-only use cases. And so the observation actually started from here. Even if you take a multilingual model and do a preference training in English-only data, using English-only data, your model might get better, but potentially we lose lots of capabilities or we lose performance in other languages. So you really need to do multilingual RLHF. But of course, then the question is, how can you have a multilingual data here, right? So in the paper, we actually presented a simple framework to contrast translated data with naturally generated data, because translated data has lots of different translation artifacts. I believe we will have a more deep dive on this later. But also, I mean, but we also in the IR 101 time we observed these different artifacts. And in the paper we showed that even with very simple this data generation pipeline, you can have a preference pair. But in the IXPan's time, we actually combine this synthetic generation pipeline with the arbitrage idea, because in the arbitrage setup, we already have multiple generation for each prompt, right? So this allows us to kind of build more fine-grained contrastive pairs for preference training. But it's not only about the data. Even if you have data, you may not get the best of it for RLHF. And our findings here in the multilingual LLMs on policy learning is extremely important. So if you only use of policies, simple direct preference optimization, for example, it does not improve as well as you may get. It does not reach the potential, let me say in that way, because your LLM that you start from, your policy, may have different level of performance in different languages. So you really need to get from the model either using purely online RL techniques, or maybe some on policy iteration using maybe online DPO or on policy DPO. And the last pieces in the IXPan's was a model merging. This is particularly interesting and important, I believe, in the multilingual models, because when you are training a multilingual model, you have a multitask complex objective problem, right? So you want to optimize for multiple languages. Each language has multiple tasks. So mathematic, for example, you may want to optimize for maths, but also instruction following, but also maybe code in multiple languages. So this is really a complex optimization problem. And oftentimes, to solve this problem, you need to really find the best mixture. But this is also really costly if you really want to do a sort of grid search to understand what data mixture is best. So instead, here we presented in also another paper, you can delegate some of the mixture experiments from the data space to weight space. So you can train different models with slightly different objectives, maybe for different languages, grouping languages, or for maybe different tasks. And when you merge them, you can have actually sort of Pareto optimal performance in different angles. And we also incorporated this idea into IXPan's in the iterative manner. Starting from supervised fine-tuning, we train different experts, merge them, and then train different experts with the preference optimization and merge them again in multiple iterations. This is how our IXPan's recipe looked like. It starts from the arbitrage, but also actually it starts from IR 101, because we also use the data that we kind of created from the IR 101, but also we increase the volume of synthetic data much more with the arbitrage, applied merging, and preference optimization in iterative manner. Especially for the iterative preference optimization, as I said, is particularly important because of the on policy characteristic of it. So this is very simple, like I kind of showcase the final results, but also shows every component that we added into IXPan's models actually improved the performance from the base. When we include multilingual arbitrage, it increased like a 9%. This here, the baseline is Gemma 9B, and this is the 8B model that we trained. And when we add also merging and then iterative DPO preference optimization, we went from 39 to 60%, which is a very significant improvement. And then one nice thing about this recipe is actually you don't need to lose in English, because this oftentimes you will see in multilingual optimization problems, but you can actually improve in many languages at the same time, which was really, really critical for the model training. This is just to show like it's not only for human preference evaluation, but also you can still get the performance with a higher performance with the conventional benchmarks as well. But also nice, one more nice thing, the recipe that we kind of designed and applied in 8 billion scale model, it can also be very scale up to a larger model size. So we just apply the same recipe from 8B to 32B, and also 32B model that really gets very, very strong results compared to much, much bigger models like 70B or even a larger mix of expert models. So very briefly, from AI expands, I think let me put all of them together. So the most important thing always starts always the data, right? Everything starts with the data. So in the data, in case of multilingual LLMs, you really need very high diversity, but also evaluation that I very briefly mentioned, didn't go deep into that, but evaluation is really, really important. We presented some framework in IA 101. And to the IA expanse, much more stronger base model, but more importantly, multiple different like it's like a flavors I say, but our experts or like multilingual post-training recipe really make the performance in the highest bound. And also when you have a higher performance model, then of course you need to evaluate in higher, more challenging benchmarks, right? But I mean, this was only some set of research that I prepared, but in multilingual scale, I think there are much more like a missing points or the gaps that we can collaborate or we can research for. I listed some of them here, like at least IA expense model was for 23 languages, IA 101 model for 101 languages, but there are much more languages in the world, right? We should definitely scale up in terms of the language coverage. Also, we should build much more realistic benchmarks, more culturally sensitive benchmarks, and so on. So there are a lot to research on, a lot to collaborate. So as I said, this was like years of research. So many people involved in this. So I would like to thank all of my collaborators here. And yeah, thanks again. That's all from my side.
Thank you, Ahmed, and thank you for the beautiful slides. I think we have time to take one really burning question from the chat, and our guest wants to know, how do you come up with the ARIA name for models?
So if somebody knows the language, please correct me. But I think Aya in one language means some resilience, I think. So when we are like discussing about the model name in the Discord, Cohere for AI Discord, there was lots of these ideas, and the Aya stands out with the meaning. So I'm not able to remember perfectly now, but the meaning, but also how it sounds was really, when I think Sarah said Aya, then everybody, yes, let's go for it. So it was kind of an Aya moment for us. But yeah.
What language is it?
I'm not exactly sure, but I will find.
Okay.
And I will post here.
Okay, thank you so much. And then we have the next speaker, Evgeniia. The floor is yours.
Hi, thanks a lot for the invitation. It's really good to be here and finally talk all things multilingual. I think I have a much easier job after Ahmet, but here we are. I would like to talk to you about sample efficient learning for multilingual NLU. To begin with, I would like to explain why we unavoidably will need to think about few short when we are thinking about multilingual NLP. Quite frequently, we are talking about multilingual models, and we're thinking about how many languages the model supports. Like, for example, the latest one, IA Expand, supports 23, and that's quite crucial because it ensures the access of the users, of native speakers of that language to the model. So the model can understand their language and respond in it. But the other side of multilingual NLP, which is spoken more rarely, is actually what I call usefulness. But in reality, what I mean is that the responses that the model gives are actually applicable to the target language user's realm. And that means that, for instance, German speakers could be more interested in finding out information about, I don't know, banking, while Italians might be more interested about types of pasta. Sorry for the stereotypes. And therefore, because we need to cover both different domains and different languages, we are unavoidably going to be in a situation where having enough data for every language domain combination is very unlikely. Therefore, we wanted, given that we now live sort of in a world where we always have new models, new methods, and new approaches coming up, we wanted to find out actually which of them works best in practice, and also which one provides an optimal entry point for every language. To this end, we have decided to compare 3 de facto standard approaches which exist now. One is supervised fine-tuning, so where we have task-specific data and a multilingually pre-trained model. For the simplicity here, we're going to assume an encoder model, and we fine-tune this model on the given data. The other approach is in-context learning, where we have a number of labeled examples. We modify their, let's say, appearance, and we provide them in the input in the context to a large language model, and expect the model to, without any fine-tuning, to be able to complete the task. And the last one is what we call supervised instruction tuning. So here we do both motivations. First, we slightly change the data so that it is more similar to the instructions which the models have seen in their instruction tuning stage. And then we further fine-tune the models on that data. Because we're going to be doing supervised training here, we can afford to use much smaller models than in the in-context learning one. And because we are interested in kind of real-life entry point for every method, we take a broader look on what it takes to tune or to prepare a given method for a language. And that means that an performance or task performance, which is kind of the standard evaluation, is only one side to this. We also look at which methods are more sample efficient, or how much data is required, what is the computational cost, or how much memory do we need to store the model and to fine-tune the model if it is a part of the recipe. Then what is the inference cost, or if we are, for example, thinking about any live tasks, how long will the user need to wait to receive a response? And lastly, a more general and down-to-earth financial cost, or how much money do we need to get to high performance. We kind of tried to keep the experimental setup as fixed across languages as possible, and made sure that the same few short examples are trained for all of the languages and across the methods. We focused on 3 languages: English as our high resource language, Marathi as a medium resource language, and Amharic as a low resource language. This is for the purposes of this presentation. The paper, which is linked through the QR code, has many more examples, and I invite you to have a look in there. And we tried to compare the approaches that I described in a way that there is one model which is more English-centric, like FLAN-T5, and the other one which is multilingually pre-trained, like MT0. And we also compare it to in-context learning with GPT 3.5, which was back then latest, best, and greatest. Not anymore, but that's how we that's how we roll these days. Starting to look at the results, what we observe in here is that in terms of data efficiency, supervised approaches are more sample efficient than the in-context learning ones in the context of multilingual approaches. But what the difference is in between with respect to different training data set, training sizes, really depends on the language. For instance, the turquoise lines correspond to the best performance obtained for English with 100 examples. And as you can see, for example, Marathi gets to the same performance with 500 examples, and Amharic really never gets there, even with 10-fold more data. Therefore, it shows the difference in how much data we need for each of those languages. When we look at the cross-domain results, as I mentioned, that we do need to think about that, given the adaptation across cultures and domains. The picture is similar, but well, I would say even worse for medium and low resource languages, in that here Marathi needs essentially 10x more data than English to reach the similar performances, and Amharic, again, never gets there. One thing which I think is interesting to note in here is that what we see across the board is that supervised instruction tuning performs better than just supervised fine-tuning for a given task. And we assume that this is because within the instructions, we can also provide more information about the domain and about the expectations of the task, which helps the model to perform it even in very low resource languages. Further, when we compare in and cross-domain results side by side, you see here this really nice looking stairs. I would really like to have all of the bars at the same level and hope we'll once get there. But for now, what we see is that the lower the resource languages, the worse the performance, and it's sort of it's kind of steady. Further, looking at the practical costs, which I have described in the beginning, what we see here is that it is by far not always the most complex, the largest model that performs better. In reality, what we see is that, for example, for Amharic, the performance for which I'm giving here, the smallest and most multilingually pre-trained model, XLMR, actually performs best, which might not be the case, for example, for English. On the other hand, when we look at the financial costs, the largest cost that we have to go through here is data collection. And with supervised training, we can essentially use as many examples as we want, which raises the cost. But for in-context learning, we have this natural limit of the context length of the data. And therefore, I think given this balance that we have to hold in mind, we need to think for every application what are the limits, which costs we are ready to take on, but also to remember that the higher the costs, the more entry barriers there are for different languages in the multilingual world. And to conclude all of this, I think all of this shows that we need to do way more for kind of culture and language aware modeling, that we're far from perfect world in this. The entry point for many languages, especially for low resource languages, is very high. And it is kind of counterintuitive because the lower resource languages need the LLM tasks more, probably, in some sense. So I think there is, as a research community, there is way more to be done in here. We need to kind of, continuing on Ahmet's thread, we need to create more resources and benchmarks which are designed with more culture and language aware mindset at the center of them. But also I think we need to remember that as developers with great power, we sort of get great responsibility, and we need to make sure that the technology that we create actually is helpful and doesn't hurt the speakers of different languages. Thanks a lot. Happy to answer any questions if there are any.
Yeah, thank you, Evgeniia. We have one question that I would rephrase for the sake of simplicity. So, in your experiments, how do you think what is the role of the tokenizers and what is the role of the model? So does the size of vocabulary, because I assume it's different for different languages, affect the performance much?
I would say it does impact, and therefore there are some papers which do tokenizer transfer, but I have not done any experiments within this work which explicitly experiment with that. If
Okay.
anyone knows of any work on that, I'd be very happy to read.
Okay, so thank you so much for the answer. And again, if there are any more questions and if you have experience with multilingual tokenizers, feel free to add something to the discussion and chat, and we'll look through the questions a little bit later after we're finished with the first part with the talks, essentially. And next, we have the talk by Patrick. Patrick, the floor is yours.
Okay, can you hear me? I guess so.
Yes, we do.
Thank you. So, yeah, I love that with great power comes with great responsibility. I think one responsibility for us researchers is to ensure that our evaluation is trustworthy. So, beyond modeling, I want to talk about how the use of translation, automatic translation, may distort LM fine-tuning and evaluation outcome. So we all know that most LLM pre-training is English-centric. That means most of the data comes in English, for example, from the early GPT to the latest Llama 3. So when we get this kind of open source based models, we may want to extend their language capability. So the first thing usually comes to our mind is that can we translate post-training resources to achieve this? And by post-training, I want to focus on instruction tuning, or as known as supervised tuning, where you fine-tune a base model on input-output data. So if you introduce translated instruction and response data and fine-tune your LLMs on, you may also need to translate some evaluation benchmarks to test your models. You may realize that there is a problem with translation. For example, the process can corrupt your language. Also, sometimes there is a mismatch of the use of words. Like here, I learned it from a friend when I showed them a German translation that they told me that you rarely use the former C when you talk to a large language model. So the use of both translated data in the training process and the evaluation process may hide this problem. Just think that if your instruction data is about US history and then you translate it into French, and then your test data is also from the US domain, yet you translated it into French, so your model may perform pretty well, but when a native person speaking French uses this model, they may not feel very comfortable. In our current landscape, I took this picture from Llama, where they claimed multilinguality in about 30 languages, but their benchmarks are all translated. Another voice rises that, through instruction tuning, it's only about superficial alignment, where the process changes the response format and also teaches the model instruction following, but no knowledge is modified in model. So this may not be a problem for using translation. Therefore, we wanted to conduct some controlled experiments to study more about the use of native or translated data at both training time and evaluation time. So for training, we gathered native data, which is Aya, as Ahmet mentioned before. We also translated the English portion of that data into using Google and LLMs. So here the LLM translator is Cohere command. For evaluation, of course, we found translated benchmarks as well as natively created benchmarks. Another thing we think is important is classification versus generation, because if a model has learned translation needs, this may reflect more in generative tasks. And now we have this 4-quadrant split by classification versus generation and native versus translated. We could place some test sets in this diagram. So on the left-hand side is open-ended questions and translated open-ended questions. On the right-hand side, it's our famous or well-known benchmarks like MMLU or native MMLU. And I put MGSM in the middle. So this is a grade school mathematics test set where you can test it using chain of thought, which is generation, or you can ask it to directly answer your question. And we fine-tune a bunch of models that it includes like Llama 2, Gemma, and also Quen. So these models were pretty new when we conducted the research, of course. So on the left-hand side of the diagram, we took the generative or native benchmarks here. We see that when we fine-tune large language models on native data, which is represented by the leftmost bar in dark blue, we see that there is a slight advantage for those natively fine-tuned models. But on the right-hand side, we see that when we benchmark the 3 types of models on translated classification benchmarks, the advantage actually disappears. So that means if you test on translated data, maybe your translated fine-tuning data will work as well. And furthermore, we plot this Pearson's correlation between native data performance and native translated performance gap. So for generative question answering, we see that when the native data has a better performance, the gap also enlarges. So that also means when your model is not performing very well, maybe the source of the data will not have a really strong impact on the outcome. So what is the cause? So just now I said that maybe the translation process can corrupt your data, or maybe the translation process just couldn't introduce any target language knowledge because the topics people talk about, the entities people mention are always associated with the source language. So we used round-trip translation to study this. On the left-hand side, you see that if you translate it from English to another language, then you can introduce both errors and misrepresentation of knowledge. But on the right-hand side, if you start from native data and you translate it to English and then back into that language, you may introduce a lot of translation errors, but the topics or the knowledge or the culture stays the same. We ran our native models on 2 types of translated or round-trip translated data. They come from Cohere command or Google Translate. Here we find that the RTT, which stands for round-trip translated data, actually leads to consistently better performance compared to data translated from English origin. So that means it's very important to have native knowledge compared to dedicating our effort in reducing translation errors. And while we were doing this work, OpenAI released a really nice human translated MMLU where they said this is done by linguists. So we wonder about whether this kind of human carefully translated benchmark can be more useful. Here we compare machine translated MMLU and the aforementioned human translated MMLU. Unfortunately, we saw that the patterns were very, very similar on both benchmarks. So for example, when your native model is better, it's better on both MT-MMLU and HT-MMLU. And when your native models and translated models are very close in performance, this is reflected by both benchmarks as well. So this means that unfortunately, by using human annotation, we may not get any extra benefit. Of course, this could also mean that now the machine translation technique is pretty strong enough to squeeze out the performance gain we can get from human translation. And finally, we have a small-scale study on the judges' behavior. Here we feed those models translated questions or native questions, and they are judged by Command R+ from Cohere or GPT-4 from OpenAI. So these were the best models we could find. As you notice on the bottom left corner, the native models are consistently better than the other 2 translated models. However, this is not very obvious in other 3 diagrams. But unfortunately, because the judge are like black box models, we could not have much information about that. Maybe one reason is that during the preference learning stage, maybe other models have used translated data already, so they could not really tell the difference. So just in summary, sometimes translated multilingualism is favorable. It helps you with benchmark scores. However, if you want to fine-tune your models, it's still better to use native data. And we also found that language native knowledge or culture is very important. And finally, as corroborated by some other work, we find that generative benchmarks are probably more useful compared to classification tasks. So you may ask, okay, so we have so many languages, how do you really tackle this problem without using translation? So the first point is to further push for open source and collaborative effort, as the two speakers have mentioned. Also, I think it is now the time that we can use LLMs to help us in creating data or benchmarks. And this was actually done by Li et al. In 2023 in their work called BacktrainX. And finally, we have a long tail distribution of all the languages. We can conquer some, but maybe it's really difficult to cover all the languages. And actually, culture and knowledge may not really be generalizable, in the sense that if you train your model on one language, one culture, it may not magically know the other languages or other cultures. So maybe here, one way forward is that we can treat our model as an agent that can interact with external environment, so that maybe the model behavior can be influenced by retrieval-based techniques or context memory, right? And another opportunity is to produce specialized smaller models for each language, of course. So thank you very much. That's me.
Thank you, Patrick, and thank you for the talk. I'll again ask a small question that is inspired by our chat. So as far as I understood, you use two systems for machine translation. One is Google Translation, that is very easy. You input something and you get the output, and then you've used large language model Kommandar for translation. And in the second case, do you think there's a pronounced effect or impact of how exactly you prompt the language model for translation? So in chat, they ask, do you think that the nicer you ask your language model to translate, the higher results you might get?
I hope so. So I want to elaborate a bit about the use of LLMs. So we use LLMs because we can control the prompt, as you said. And one important use of it is that we can make sure, or we can ask the model to not modify the template or the format of the response. Because sometimes we get coding, we get math, we get quotation. We do not want to alter that. And regarding the specific question about if you ask nicer, will you get better results? I am not sure, honestly, but there are other prompting techniques that can give you maybe better results. For example, you can ask a model to do chain of thought, or you can ask for some initial draft translations and then feed it back for further refinement. Yeah. So yeah,
Okay.
Thank you again. Oh, yeah, I will post the link to the chat as well. Thank you.
Yeah, thank you so much. And we'll take other questions from the chat a little bit later. Yeah, now we have the next speaker, Patricia. The floor is yours.
Hey, good evening, everyone. My name is Patricia, and I'm very happy to be here and to talk about evaluation of generation without references. So why should we do referenceless evaluation at all? So the first reason is that generation is by design very open-ended, and there are many ways to say things. And just because an output is not similar to a reference that we have in hand, it doesn't mean that it's necessarily bad. A second reason is that we have many custom systems in production that are generating new text every day. And for this newly generated text, we also don't have a reference. So it is very desirable to have a method for quality estimation of the generated outputs. Then, even in research, it can be advantageous to use referenceless evaluation to avoid data leakage by scraping new data and being able to use it without a reference. And last but not the least, gathering the references is the most expensive and most time-consuming portion of collecting a dataset. And referenceless methods allow us to skip this, at least for some small datasets. So how is evaluation actually done? So we did a survey and we found out that the vast majority of evaluation in natural language generation is reference-based. And the second most prevalent type of evaluation uses the output only. So that's generally diversity of n-grams and so on. And there's a very little proportion of metrics which actually measures some relation or grounding of the output with respect to the input. And if we look in even deeper and look at specific metrics that are generally used, we can see that BLE is the most frequently used metric for evaluating natural language generation, which is bad for two reasons. First, it was not even designed for natural language generation. And the second is that there are multiple works that show that a higher BLE score doesn't necessarily correlate well with a better human judgment of a text. So maybe we can just train a model to provide a direct assessment of the generated text, right? So in practice, this can work. However, there are caveats with when multilinguality is involved. So the first problem when using LLM judges to generate scores is that they tend to give lower scores to low resource languages and thus discriminate them. So that's not necessarily something that we would want. And we see something similar even with Comet used for machine translation, where if a language pair is difficult to translate, then in the training set, it was more frequently labeled with a lower score, and therefore a difficult language pair will receive lower scores even if the translation is actually good. So how can we do it differently? So instead of giving a number to the outputs, we can actually focus on the specific parts of the output that are incorrect with respect to the input. So for example, in data-to-text generation, if we have data saying that the weather will be cloudy on Monday and Wednesday, and it will be sunny on Tuesday. However, we have a text which says skies will be mostly clear. This is not true because the skies are not clear on Monday or Wednesday. And the information that winds will remain strong is something that's not checkable because we have no information about the wind. Similarly, in machine translation, the smaller grammatical error jump instead of jumps is a minor error. However, mistranslating the word hund to fox instead of a dog is a major error which changes the meaning of the sentence. Last but not the least, we can actually use this to tag different fallacies used mostly in propaganda. So for example, a blanket statement saying a study finds is an appeal to authority. So can we actually automate this process using LLMs? We compared this by having gold annotations and using crowd workers for collecting annotations. And we found that LLMs are actually on par with crowd workers in data-to-text generation. Now, the results vary per domain. However, they were able to generate good judgments for the weather domain. And in the dashed lines, you can see the level of human agreement. So this is something that we use as a baseline when we analyze the performance of the models. And the grayed out portion of the bars tells us that the model was able to correctly identify that there is an error in a specific part of the text. However, the shared screen is gone. Katya, can you share the screen again?
I think there was an issue on my end. There we go.
Thank you. Okay. So the grayed out portion of the bars tells us the model was able to identify that there is an issue with the span in the text. However, it was unable to identify the specific type of an error that was wrong. So this is still useful for knowing that there was an error, even if the category of the error is not good. And for machine translation, the humans that we compare against are actually professional translators and translatologists. So here the bar is higher, and we can see that the models are not quite on par with them. But let's have a look per language. So we can see, as you probably noticed at the first, English to Icelandic actually performs quite well, which is good news because it shows us that low resource languages are likely not being discriminated. And it is also good because we estimate that the Icelandic data for the WMT shared task of last year were very good. So this means that there is a higher agreement of an LLM judge with high quality annotations. On the other hand, you might notice that the performance is not great for English to Hindi. However, there we estimate that the human references were not as good as they were in the other languages. So we can see that even though the performance varies by model and it varies by language, there is not necessarily a clear trend in terms of lower resource languages do worse. We can see that if a language pair is more difficult to translate, then it can also be more difficult to evaluate. However, this is still subject to the quality of human annotations that we have at hand. And another thing that we noticed is that compared to humans, LLMs tend to over-annotate quite a lot. However, this ratio of over-annotation tends to be relatively stable across all language pairs. So it's not something that would change between different language pairs. Now, how can you actually try out span annotation? So let me present our tool developed at Charles University called FactGenie. And it allows you to store and look at annotated outputs. You can even use it to generate your own outputs, or you can upload them and set up an LLM or a human annotation campaign. You can link it with Prolific, and then you can use it to look at the inter-annotator agreement or the distribution of errors in your datasets. So how can we move forward? So if you happen to have any annotated model outputs with human scores, please release them because this kind of data is very, very useful for validating different metrics and also for potentially in the future training a dedicated quality estimation model. And when using LLM as a judge, they have proven to be on par with crowd workers. However, their performance depends on the domain and the task. So make sure to always manually validate at least a sample of the LLM annotations. So summary, there is still work and a lot of it to be done in referenceless evaluation. However, I believe it is a powerful tool and we can use it to evaluate novel tasks that don't necessarily have references yet. Direct assessment seems to be unfavorable to low resource languages. However, on the other hand, LLMs as span annotators are comparable to crowd workers, but not necessarily reaching the level of translation experts. And if you would like, you can use Evgeniia to try out span annotation yourself. Here are the references I used in the talk, and before I move over to the next speaker, let me invite you to participate in the first multilingual instruction share task. The first wave of deadlines will be in the beginning of July, and there will be 4 subtasks so that we can really measure how well multilingual LLMs perform on a range of tasks. And anyone is welcome to join, regardless of whether you're from academia or industry.
Thank you, Patricia, for the talk. We don't have many questions in chat, but I ask from my end something that maybe I've missed due to my lack and back and Wi-Fi connection. Isn't it true that LLM judges also suffer for low resource languages, or do you think that they are better in judging than in I don't know, producing low resource languages?
Yeah, that's what I mentioned, that especially if producing direct assessment scores, then LLMs tend to be biased against low resource languages. So the scores are definitely not comparable across languages.
Okay, yeah. Thank you. Sorry that I might have missed that.
No,
Yeah, and thank you for your talk. I think we have one talk left, and this is mine. So just a second. I need to get the remote control on my end. And wait. Sorry, everyone, but I can't control. No, I can't control the presentation.
Maybe you could
Is everyone?
restart sharing.
Maybe. Oh yeah, it's back. Okay, good. Yeah, thank you for the advice. Right. So I'm going to talk about our recent release that is called GIM. This is a vision language benchmark. It tests vision language understanding and generation in 4 Arabic dialects. Basically, we have 2 tasks that are supported by the benchmark. This is image captioning and visual question answering. And the language that the benchmark supports are Modern Standard Arabic as a site language, and 4 local varieties, namely Jordanian, Emirati, Egyptian, and Moroccan. And here on the slide, you see an example of how each instance in GIM looks like. So if we have any Arabic speakers in our meeting right now, you can probably read it. For everyone else, there's a translation, and they encourage those who can understand the data, maybe put some comments in chat or something, and tell you what do you think, and tell us what do you think. Anyway, the benchmark consists of images. Images are collected from multiple sources that are the permissive licenses. For each image, we have 2 types of image captions. One is in dialect, and the second one is in Modern Standard Arabic. So here you see an image that was taken, the photo was taken in Morocco, and then respectively, the caption is in Moroccan Darja, and then it's translated to Modern Standard Arabic. And also, each image is equipped with a set of 5 questions and answers that are related to this image and to this caption. So that way we support 2 tasks. Why Arabic? Basically because it's one of the most largest one of the largest languages spoken globally. So there are more than 300 million people who speak Arabic as a primary language. But from a linguistic point of view, it's very unique because Arabic is extremely rich in dialectal varieties and in dialectal diversities. So there's a lot of local spoken languages that differ from modern standard Arabic in terms of pronunciation, vocabulary, grammar, and syntax. And for language models become more fluent in Arabic, we need to develop resources, of course, that support all of these dialects. Otherwise, they would be not useful for the local communities. So how Gene was collected. So this is something that was carried out on the Toloka platform, of course, because Toloka is a data collection platform. So that's what we were proud to handle. First of all, the introductory part was image collection. As I mentioned, we collected images from open resources such as Wikipedia and Flickr, but then we also our co-authors contributed by some images from their personal archives, and this work is done in collaboration with the Mohammed bin Zayed University from the UAE. So we had collaborators who are native speakers of all four dialects that we are interested in here. And then the other steps were carried out by Toloka workers. On the second step, one of the annotators was presented with an image, and they had to write a caption in first the dialect and then translate it into MSA. Here we figured that it's better when they start writing first in dialect, because then their writing is very fluent, native, exactly the way they would speak, rather than when they start with MSA and then translate it to dialect. So this consequence hinders a little bit of how fluent the text is. And then another annotator, and this is important that the second person differs from the first one, another annotator is presented with the image caption, but they do not see the image, so they see only the caption. And here they have to ask 5 questions that have to explain something or detail something that is going on in this caption. So they ask for more details, essentially. And on the final step, the third annotator, who could be the same person who was involved in image captioning, doesn't really matter here. They are presented with image caption, with image, and with these questions, and they have to answer the questions. So the statistics of the data sets are the following. We have more than 500 instances from Jordanian, Egyptian, and Moroccan dialects. And of course, the Emirati dialect being the low-resourced one and being the most difficult to hire annotators who are native speakers in, has the lowest image count. So we have 150 images from the Emirates. And the images cover very different topics. Places are the most prominent ones, and then we have a lot of images related to nature, transport, and then there's a lot of different things going on from all 4 countries. And then needless to say that each team of annotators, they of course worked on images sourced from their regions, but what we also did is we created a shared pool of images. So this one consists of 100 images that were shared across all 4 teams, meaning that, for example, this image, it was annotated by native speakers of all 4 dialects. And here you can see that not everyone, not each annotator did correctly understood what is presented, what is shown in this image. So this image was sourced from the OIE, and others struggled a little bit with understanding what exactly is going on here. And that's exactly the point why we need data from native speakers, from their native cultures, and so on, because you can, for example, say, but this is somewhere from the Arab-speaking country. Why not we hire people from all over the Arab-speaking world and make them annotate this data. But no, actually, if you want to dive deeper and develop something that is useful in daily life, for example, something that people will be able to see in coffee shops and so on, like this suite, you actually need people who are familiar with these things. So you need native speakers who would be able to annotate this sort of data. And then in experimental setup, we used 5 VLMs that are open sourced, including the recent release by Cohere, the AI vision model. And we used also GPT-4o as its as probably the upper boundary of performance. And this might be a little bit problematic. I'll get back to this in a few seconds. And then for the evaluation metrics, we did human evaluation for image captioning and for image captioning and for VK, so for both tasks. We also employed surface level and embedding based metrics, as well as LLM as a judge paradigm. And here comes the problem with the GPT model, because we used another version of GPT as a judge. So you may tell me that there is a source for bias here, that one model is used to produce outputs and the model from the same family is used to evaluate these outputs. And yeah, it can be a little bit problematic, but still GPT is kind of the model of today. So we still stick to this approach. And for this LLM as a judge approach, we judged all outputs according to 4 criteria. 2 of them, consistency and relevance, I would say, judge semantic aspects of the image caption or answer to the question. And fluency and dialectal authenticity, they judged more like language-specific things, like how fluent and how natural is the output, and also how correctly does the VLM produce the requested dialect. And here, what is important, that in fluency, an output can get high scores either if it's in MSA, so the MSA is perfect, or if it is in dialect, so it doesn't distinguish between MSA and dialect. And dialect authenticity judges exactly if the dialect is correct. So here you can see the results of human evaluation of image captioning, and you can see that VLMs perform pretty well in consistency and relevance, but they also do perform well in fluency. However, in dialect authenticity, the vast majority of them get lower scores. As we had this human evaluation of image captioning, we also did correlated to the outputs of the LLM as a judge. We received relatively high correlation between those 2 approaches. So I'll skip the LLM as a judge evaluation of image captioning for the sake of time, but you can probably trust me that the situation there was more or less similar. So high in semantic criteria, lower evaluation scores in dialect authenticity. And for question answering evaluation using now GPT as the judge, you can also see similar tendencies. So fluency scores remain high, dialect authenticity remains low, meaning that most answers most likely were produced in MSA rather in dialects. But now the consistency and relevance scores lag significantly behind those that we got for image captioning. And that means that most likely VLMs are able to produce more or less coherent caption of the image, but they don't have a deeper understanding of this image, so they're not able to answer the questions related to this image. So this is probably because we test for 2 different skills in different setups. And there's no clear winner among all the models we tested. Some of them are better in understanding, some of them are better in producing dialects, but nevertheless, you cannot say that there's one that outperforms in all 4 dialects and according to all metrics that we considered. So to sum up, GIM is a novel dataset. It leverages everyday images and tests language models in settings that are very close to real world settings. So these images are very close to daily life. We see that modern VLMs struggle with the Arabic dialects, and this limits their accessibility in diverse community. We also kind of slightly show or somewhat uncertainly show that LLM-based evaluation is efficient with low resource varieties and with dialects because it's not perfect, but it's more or less correlated with what human can do. And yeah, although we can probably claim that GPT-4o leads along all other models in our evaluation, still we see that performance varied across Arabic dialects and there's no clear winner. So please feel free to download GIM from Hugging Face anytime and use it in your own experiments. And I'll be happy to take any questions from the chat a little bit later. Right. Now we're done with the talks and we move on to the next part of today's webinars. And this would be a panel discussion. So we have a set of questions that we prepared to our speakers today. And while we discuss these questions, of course, feel free to add something else to the chat and we'll see where the discussion will take us. And I'll start by the first question that is aimed at everyone. Again, feel free to add your answers in your chat if you have something that we forgot to mention. The first question would be, why do we actually need multilingual LLMs? And who's gonna take this question? Or do we have a brave one?
I can start.
Go.
So
Go.
I guess the first point is that not everyone in the world even speaks English, but even the people who do speak English, if they don't have a background in NLP, then they would never really think, oh, maybe I should use English to speak to this LLM because that's a high resource language and my native language is not high resource. That's not generally how the users of LLMs think. So in order to make this technology accessible to anyone all over the world, I believe that multilingual LLMs are the way to go.
Why do you think? Oh, okay. Sorry.
I can
Go on.
quickly maybe add one point from an industrial perspective. So multilingual LLMs also help us with efficiency. So imagine that if you want to build separate models for every language, then if you have n languages, then you end up with n models. But even worse, if you care about translation or cross-lingual problems, then that becomes a quadratic number of models. So this is also a motivation for us to put all the languages in one model.
Yeah, I would also add what Patricia said. I think accessibility of these models are, of course, our main thing, right? So we want to build models that are more accessible, but actually there is beyond, because these models are becoming like a main workforce for the industry. So this actually, if we don't have multilingual models that works well in other languages than a handful of higher source languages, this the asymmetry in terms of financial asymmetry is also getting much more deeper. So it's actually really like a black hole of a circle. So we need to break this because I mean, otherwise a part of world won't be able to leverage this workforce. I think that is as important as being accessible. I think that's why like even small or specialize on some domains, we definitely need to build multilingual models.
I think I would.
Evgeniia, yeah, sorry.
I just wanted to add one sentence to this, and I am a bit scared of sounding a bit like, well, good, peace, love, and chewing gum. But I think there is a bit of I don't know, democratic value in this, in that we all try to work on technology which makes the world better, which makes the information more accessible, and trying to make it accessible equally across languages is actually a very nice aim to have in your mind.
Yeah, thank you, everyone. We also do have a note from chat from Ivan that there is a lot of knowledge in languages other than English, and we probably can benefit from using this knowledge in multilingual LLMs. Right. The next question would be, if you would have an infinite resources, what would you work on? Patricia, do you want to be the brave one and start with this one again?
Sure. Yeah, I think I'd still work on evaluation and making it more accurate, making sure that we are actually optimizing the right things, because you improve what you measure. So I really would, devote my endless resources to making sure that we are in fact measuring the right things.
Ahmet, what will be your take on this? You are more on the training side. What would you train if you have infinite resources?
It's cliche, I guess, but I would also annotate data, I guess, with the infinite resource. I mean, evaluation data set is part of it. That's extremely important. Beyond, I think that we know that maybe not the volume now, because I'm a huge believer of synthetic data with different forms, of course. There's very active discussion about that, so it's not for this discussion. But still, we really need diversity, including the language diversity. Also within a language data, we need more diversity, which is oftentimes it's only possible with human annotation. I think that is one way to go use the resources. I mean,
Yeah,
of course, I
so
would scale up all the models to large parameters.
so you're thinking about different type of resources, like if you had an access to like human workers, right, and budgets and so on. Yeah, that totally makes sense, I think. We also have a comment from Patrick on chat. Do you want to elaborate on this, or do you want to read me aloud?
No, sorry, that was a joke, right? If you have unlimited
Yeah.
resources, you just need to sell the resources.
And what do you do next then?
Yeah, but I do
Evgeniia,
think
do you have to? Sorry.
I think the next question is quite interesting. Like if you have text versus speech, maybe we could try to convert from one resource to other formats, other modalities, right? But of course, this is also linked to like annotation in general.
Shannon, what would you add here if you had infinite resources and you would want to do something for better for the society? What would be your contribution then?
I think I was thinking about completely different resources. I was thinking about resources like infinite personal time that I'm happy to devote to this. And what I thought about is what I would love to do is to go to some, I don't know, far remote South American place and collect some data in some local languages to have a proper kind of community connect, to see how people live, what they do, how they speak about their everyday life. And I think that would be proper cross-cultural data set. But maybe I just need a holiday.
Fair enough. Fair enough. Let's say let's take a break from the questions that we have because we have some very interesting topics on chat. Um, so Yusuf is asking if any of you guys have any advice for training models or let's say evaluating models because we've talked so much about evaluation for endangered or indigenous languages. And I think it's somehow related to your ideas of going into the field again, right?
Yes, I have heavily breathed in and heavily breathed out because I mean, I think there is a lot of work, a lot of very interesting work which can be done in there. And I think that if I can't, I'm not fluent in the chat. If Yusuf, if I'm reading the name right, actually has kind of access or ways to talk to people from communities which speak some endangered languages and has ways of collecting the data and trying to adapt the models to the languages. I think it is actually really, it's a research very interesting task, but also I think the benefit that you can bring with the technology there is huge, especially if you can ask the communities about what they actually need. We had a small project on data collection for kind of medical aims where we started by asking different communities speaking African languages which health issues they found most pressing and collected the data only for that topic. I mean, for the topics in the respective languages. And that was in itself very interesting. So for endangered languages, it is one step further.
Yeah, thank you so much. Who else wants to contribute here? Anyone? Somehow? Is anyone? No? No? Okay, then let's move on to our list of questions. And if you have any more ideas, please add it to the chat. The next question is, what are the main challenges in pre-training and post-training multilingual models? And we have Ahmet tagged here as the first person to take this one.
Sure. Thanks, Katya. Also, I will combine with the question. I was just catching up. So let me start from the like a pre-training or post-training I mean for it is valid for both cases. Is like of course you have like a limited capacity, a constant capacity, let's say, and you want to put more information, right? So this is very well known thing in our field is called curse of multilinguality. I mean there are ways to bend this curse, but it's generally a valid assumption that if you have a constant capacity, there is only it's a space that you can fit more. So if instead of 100 languages, you cannot definitely put 7,000 languages in the same capacity, right? This is really a big optimization problem. But of course, there are ways to bend this curve, which is high quality data. This is valid for both pre-training and post-training. Actually, like a kind of connecting to if you have like a very low resource language, for example, that is the main thing, right? So because you don't have that high quality data potentially, what you can do. So I think the capacity is the first challenge. The second one is I try to mention in a bit during my talk is the multiple objective problem, because this is basically a multitask machine learning problem that you want to optimize for multiple languages. But what kind of balance, what kind of data mixture, these very small differences tends to be very impactful at the large scale, especially. I think this is another challenge to figure out because you cannot, I mean, it depends on the resource, but potentially you cannot do all the grid search of multiple variation of data mixture, right? This is almost impossible. So the heuristics, some intuitions are really quite important here, which is, I mean, sounds maybe not super scientific, but as we all know, these intuitions are quite important. Like one intuition which is validated by by the research is like if you have similar languages in your similar high resource languages, potentially Adding more lower source languages to the mixture would be maybe much easier than adding much far or much distant language. So connecting again the question, like if you have a lower source endangered language, maybe you should pick a language model that has some languages close to your language, right? To start with. That would be one idea. Of course, beyond the data and everything else. I think these are the main challenges. But I also want to connect finally the evaluation, because we are having we've been doing this multilingual research for some time for post training, but also we have some projects focusing on pre-training side of things. In both cases, like how can we evaluate? How can we get some meaningful signal in the small scale experiment was probably the hardest thing that we are facing, because you cannot, of course, train for trillions of tokens just to get a small signal. You can only train a small model for a small number of tokens. Then how can you get some signal that model is learning in multiple languages? I think finding this out would be pretty useful for multilingual training research in general.
Yeah, thank you so much. I see a lot of questions in the chat about whether there will be a recording or from someone who is joining us late, so don't worry. We'll publish the recording and the slides a little bit later. So if nobody has missed anything, everything will be available afterwards. And then there's a question on chat that is also related to the next one in my list. So the question is related to the ways how we can, in the best way, align these models with culture. And I think it's kind of related to the challenges in creating benchmarks, because there's this kind of, I don't know, more or less standard understanding that, for example, it's difficult to judge, but some types of very formal knowledge, it can be equally represented in different languages. So it might be not that interesting as creating benchmarks that account for some cultural aspects. So let's talk a little bit more about these challenges and how prominent the need for cultural evaluation in language models is. Patrick, do you want to take this one?
Yeah, so why do we want to do evaluation, or how do we want to do evaluation? I think the answer is that we want to spend the minimum amount of resources, and we want to figure out how well our models are performing with respect to human impression when they interact with the model. So I think my talk was about no, don't do translation, and we call for native data. I think that is always the way forward, right? If we have resources, we can invite annotators to create resources. Another thing I was thinking is maybe now the multilingual benchmarks are a bit too simplistic, that very few of them actually cover the cultural aspects. And how do we expand in this direction? Again, human annotation, or can we use LLMs to assist with this? And finally, I would say translated benchmarks may be useful if we can establish some kind of useful correlation, or if we can exploit some signals from it, especially during training or validation. If we can use a small set of translated data which is reflective of models' performance on native data, then they could be equally useful. So these are my thoughts.
Right. Thank you so much. Zhenya, do you want to add something to this discussion?
I think I have 2 points. One is actually related to one of the questions on the chat, which is that unfortunately, culture is not something that is so easy to quantify. So for every data set, even if it is natively collected, you can't really pin down how culturally aware it is, because it's not something that is where you have numbers, which is one thing. On the other hand, I do not see this as, as a room without a door. I feel like we have had a small research project where we did kind of more culture-aware data collection. And one thing which we noticed in there is that exactly as Patrick mentioned, there was a bit of expectation reality problem where the model on translated data performed really well and gave completely kind of unrelated answers on more culture aware collected data. So I think we do need to collect culture aware data even for high resource languages, because not all high resource languages are English-like, and a lot of translated data is English-like, and I think it is also something that Kata, you've mentioned in GIM. So
Yeah, exactly. Yeah, I would also add that from our experience from GIM, one of the challenges that we have had is actually like if you want to work with low resource data, it's also sometimes difficult to find people who would work on these benchmarks. So with the Emirati team, the number of native speaking Emiratis, it's kind of low. It's lower than for other regions, and then even some specifics of the culture. It's pretty difficult to find these people who would be able to participate in these projects. And sometimes for some communities, you probably need to think a little bit out of the box of how to engage people in working with their dialects and how to make it more meaningful to them. So, for example, in our case, at some point, we kind of the annotation in the Emirati team was going super slow, and then what we did, we just explained them that we are working on open source data. This is done in collaboration with the university. This would be used further to promote technologies for their languages, and that boosted the performance because people finally got the sense behind this work. So sometimes you need to, like, if you work with annotators, you always need to remember that there are real people behind your screens, but sometimes you can also need to think about their specific needs and their motivation. Of course, with when the number of speakers is very high, you can be more straightforward, but in case of lower resource languages, you need to be very open and open to communications with people with whom you work with. Right. Next question is for Patrizia. How do you see the applications of large language, multilingual language models in the industry? Who do you think benefits from them?
So, first of all, I'd like to preface my question by saying that I believe in all kinds of applications of models. We should actually start out with the use case, because recently I've seen many examples of there's this new technology, we have to put it somewhere to be cool. And I believe that doesn't necessarily always lead to the best applications. But I see several ways of how the models can be applied. So the first one is internally within a company, for example, to actually make the work of the employees easier and to maybe automate some of the more let's say laborious and manual tasks which require less human supervision, so that the employees can focus on things that are more important. Then second, coming from the company out, it can be used to provide a bigger value to the customers, whether it is being able to provide information in a more tailored or customized form. It can even mean translating into a language that is easier for the customer to understand. So I believe that there are many applications, both internally and externally in the industry, that can be very, very helpful for everyone involved. What's one application that I don't necessarily like to see is let's just replace our customer service with a chatbot. And that's something that doesn't necessarily make sense because many of the cases are individualized, and then it leads to disappointment on both sides.
I totally agree here. I think everyone here has been this annoyed customer when you call German Post, for example, and try to explain that your precious things were lost, but you need to talk to the chatbot, and that gets really annoying. I can feel it. Yeah, the next question on the list is tied back to the discussion of languages and different resources. So, how we can push forward with the low resource and high resource languages. So, what are the main tasks nowadays for languages with lower resources and higher resources, and where should we focus? Where should we focus the development of different tools for this? I would say two types of languages. However, we understand that this is more like a spectrum and a continuum of resources. Let's start with Ahmed. What would be your opinion here?
I think I would start the same point what you mentioned. This is actually spectrum, right? When we say high or
Yeah.
higher resource or low or lower resource, this is actually a relative sort of comparison. So because, for example, you can think of Turkish as a high resource languages, which potentially a high resource, much more higher resource language than many more languages, but also compared to English, it's sort of a low resource language. Even the state-of-the-art LLMs sometimes struggle for some tasks. So, but why I started with this point is that, so I think one focus area here, of course, like beyond the data and everything, but one focus area is having a degree of performance for all the languages. Because like when we are doing research, always, of course, we always look at the baseline, and for some languages, baseline does not really perform. Then a bit of performance improvement is really important. But that bit may not be really translating a use case, right? Let's say having a translation performance of +5 low score doesn't really make any difference for the use case because people probably won't be able to use it for translation. I think one target when I look at the multilingual large language models, we should be able to reach for all the languages to a certain degree of performance. This is the first task. The second task, there are languages is much higher performance, but of course the comparison is tricky as we see in the talk. But still, we should be pushing the performance to all languages to the highest bar. Of course, this is a much more difficult task, but this is the next task, in my opinion. So all, I mean, when we think about the high to low resource comparison, I would mostly think about these two things. And like how to represent low resource languages from the tokenizer to data to evaluation, and like I think these are the main focuses there.
Yeah, thank you so much. Patricia, do you want to add something here?
So I would maybe approach this from a slightly different angle, and that's the fact that users generally have no knowledge of whether their language is low or high resource, or that such a spectrum even exists. And this was something that I've experienced when the number of speakers of a language doesn't necessarily have to correspond with whether it is low or high resource. And for example, Czech is a relatively high resource language, especially if you take into account how many people actually speak it. However, on the other hand, Slovak doesn't have that many less speakers. However, it is much more of a low resource. And that's why it is sometimes difficult to explain to my family and friends that hey, if you actually want better results, it is super counterintuitive, but you can use check to achieve a better result and to actually be able to extract more performance out of the LLM. And that's something that no one would really think of without, speaking to someone who does NLP. So I think one of the reasons why we should be aiming to have some degree of performance in all of the languages is that so that the users actually don't have to think about whether their language is low or high resource.
Yeah, I can probably second this somehow. So we are working in Toloka with hundreds of people, and sometimes you would hear from them. So you would notice kind of lack of awareness about whether the languages are supported or not. So very often from people from non-English countries or non-European countries even would say like, no way that my language is supported. They do not even try to use language models and chatbots such as ChatGPT in their own languages. However, it turns out there are ways to do this, and you can teach people how to use language models, and of course much more languages are supported that people would think of. So I also think that to this question there's this side question of awareness. So how do we teach people that actually there's a lot of support, for example, in ChatGPT for different languages, and you have to try and you have to also kind of convince OpenAI, quote unquote, that there is a need in your language, right? So that's the other side of this problem. When people are so have this kind of beliefs that nobody cares about the language, however, there's a lot of work already done to it. Patrick, do you want to add something to this discussion?
I think it's a difficult question because, I feel like languages, I learned somewhere that we have 7,000 languages and there is this long tail distribution. So the more languages you solve, the more problems will come out. I would say for lower resourced languages, from a deployment or application perspective, I sometimes worry about the language resources being contaminated by synthetic data. It's like for English, maybe you now see very often that someone delves into an intricate problem, which is not very even native in English, but people's use of word could be changed by AI, and I think models could overfit more in terms of low resource language modeling, and then this inevitably is like a viscous cycle that feeds back to our knowledge about the language, which I think is pretty bad. So I would say for lower resource languages, this is one direction we should pay more attention to.
Yep. Thank you. And Zhenya, do you want to add something?
I think I was thinking about it, that we are talking about applications and how we could, extend the user base, but this application-centric mindset also has the other side of the coin, which is that, in a way, if you're thinking about this only in an application-centric way, then your thought process would be, I will cover the top 50 languages spoken by the largest population groups, and what happens to everyone else? Meh, it's fine. And I think in that sense, because LLMs have become they have become business, or have come on the business side, as research, we sort of did a little circle where at some point when BERT appeared, for example, it was only English first. Then we had a whole tree of different multilingual languages where people thought a lot about under research languages. And now we are sort of making the kind of the circle back, where most of the LLMs are more English or high resource language centric. And in that sense, we have to think more about lower resource languages. But also, I think that comes with a different side, which is that now to get better performance in a certain language, we hopefully need less data. And that means that probably there are entry points for actual linguistics into the LLM development, where you need to start thinking about how relevant, like what Patricia said, like, is Czech a higher resource? How does it relate to Slovak and Slovenian? Would it do better? Oh, but actually Bulgarian is also related to, I don't know, Polish and Russian. Could we benefit there? And I think as researchers, we sort of start to benefit from it in a different way.
I love when at some point we start to kind of I don't know how to say this correctly, but like saying linguistics will strike back at some point. We still need linguistics. It's not all that
Sure.
computation. And it, yeah, I think it's a great point, and thank you for. Yeah, we have the last question on the list, and I think it's also addressed more to Ahmet than me. What are the main strategies for training cross-lingual VLMs? So we've talked a lot about language models, but what about visual language models? What are the main challenges there if we want to build a multimodal and multilingual language model?
I mean, very, very briefly, since this is like the only question about the vision language models, maybe instead of jumping into the details, like how challenging it is, maybe just very briefly mentioning about that. First of all, like vision language models are more challenging, even beyond multilinguality, because if you look at the 5 different VLM paper, you may see 5 different architecture, 5 different training recipe and everything. So because there are less things completely standardized. And when you have multilinguality together with multiple modality, of course, things are much more difficult. But in particular, what we see in AI vision development, let's say, the training mixture, because now you have like multimodal data, and multimodal data in general, this is my observation, but correct me everyone if I'm wrong here, but multimodal data out there is much less quality, because it's still in the first phase of this bigger development. Like if you remember the first time of instruction fine-tuning came out, most of the data that we have was like, okay, prompt and single answer sort of data. In the multimodal data, this is what we have now, in most cases. Of course, there are lots of property data, but I think that's why multimodal language models are not really conversational. I mean, it's performing in a degree, but not really the way we would prefer. And this, in the multilingual case, is a much bigger problem, because there is no data to train multilingual VLMs. I think that is the biggest challenge. Also, since the techniques are much more diverse, where to add the multilinguality, maybe alignment phase, maybe like a joint pre-training phase, maybe in supervised fine-tuning phase, this is also not really well known. So we are about to release AI vision paper in upcoming weeks. We have some answers to some questions, not all the questions, but it seems like having multilinguality everywhere, including vision encoder, including the pre-training data, including the supervised fine-tuning data, seems to be very, very helpful. But yeah, I think the main challenge still is about the VLMs and data and evaluation, because actually I was gonna ask in your benchmark, because even the LLM judges, when we are evaluating,
Yeah.
much lower performing in the visual
Yeah.
in a VLM case. So that is also a problem, right? Because you want to have an evaluation automatically. So yeah, there are multiple challenges there.
Yeah. So what I can add here is that, of course, we tried when creating Gym, we try to look into synthetic data, and what we see there is obvious. If you present any language model, multilingual language model with with an image from very specific region and ask to produce text in this very specific language, it absolutely fails. So A doesn't know the language and B doesn't understand the image. So no way you can use it for synthetic data. And then the second thing is that even if you try to use in some stages of annotation those language models, like to filter data, to evaluate the quality of the data, just to speed up annotations, it doesn't work. So it might work in some very specific cases. So for example, it turns out most of the models that support Arabic, they are better in Egyptian dialect than any other dialect. So if you want to somehow build probably a filter for fluency of dialect in Egyptian, in our case of GIM, it would be the only use case where language models are actually useful. The rest should be done by hand, and the rest is very, very labor consuming.
Exactly. I mean, just to illustrate how deep the problem is, just before we released iVision, there was a benchmark release from Meta. It's called Multimodal Reward Bench. So if you look at the text-only reward models, or like text-only LLMs in LLM as a judge accuracy, is I think somewhat like a 95 or so. So it's very, very high, almost as good as human. But in the best VLM in the multimodal reward bench was about 75 accuracy. So I mean, you ask 5 questions, one of them is definitely they are not able to give a correct answer. And I'm assuming this is when you go to tail of languages, then it's much more difficult, right? So yes, starting from there, things are getting much more complicated.
Much more interesting for future research, I guess.
Exactly.
So I think we're almost running out of time, but there's one question in chat that we probably can take. So the question is, how does multilingualism impact the design of educational content or in general user interfaces? So do you guys have any experience in building user interfaces? Okay, so probably and unfortunately we kind of will leave this question unanswered because unfortunately none of us has a lot of experience with building user interfaces. There's one more comment, just give me a second, I will read it. So that's the question, but probably a comment, and tell me if you have any ideas or opinions on that. So the comment reads that there's some features or characteristic of languages that make them more efficient for training language models. Like some languages have more flow while writing and speaking. So more than high resource languages, we should focus on these languages or a proper study should happen. So I can probably rephrase it like some languages are better for autoregressive modeling than other, to very simplify this. As a native speaker of a language with no specific word order, I can only confirm to this. So for example, text generation in Russian is a little bit more boring than in English because when we speak, we change the word order almost in any way we would like, and there's a lot of also probatic and semantic meaning to this. So like word order defines more or less the meaning of the phrase. However, language models are trained to generate text as in English, and thus all generated text in Russian, they also read like a little bit blank, a little bit boring because they use very standard word order, which I as a native speaker would use, I don't know, in 70% of cases. But when I want to be more expressive, I of course would do things completely differently. That I think partially refers to this comment, but I'm not sure if I understood it correctly. And tell me, guys, if you have to add something here.
I think it's a good question. This question made me think about tokenization. So tokenization directly affects the efficiency in training and also inference time for autoregressive models. And in our experience, previously we did like translation into English and Czech. And then we made a budget for English. We think that it will apply to Czech, but it turns out that we spent much more time and credit on Czech. And then we realized that, okay, maybe it's because of the imbalance in language data, which led to Czech being like less fertile in tokenization. While it's hard for me to comment on whether certain languages are more efficient for training, maybe one direction of research we can pursue is a more fair way of tokenization. For example, pixel-based tokenization, or maybe some other technologies. Yeah.
Right. So I think we need to wrap up here, and we're almost out of time. So thanks to everyone who joined us today. Thanks for to the audience for your questions and your attention. And thank you to everyone who spoke today for your presentations and your answers. It was a lot of fun to learn from you guys, and I hope that it was very interesting for our audience too.